Now, we're done with the recall of the three laws of motion and the free body diagrams, how to draw a free body diagram, what are the guidelines in drawing these diagrams. Now, let's solve problems in Newton's laws. So this is basically a problem-solving guide on how to approach problems in statics and dynamics of particles. Okay, so here's some problem-solving tips for you guys. So first, syempre, ang una mo munang gawin, other than starting with the free body diagram, identify mo muna what are the forces acting on the system, or what are the forces acting on the particle, or what are the forces acting on the object. Yun yung pinaka-importante kasi once na kulang yung forces na nag-act sa object na yan, mali na magiging sagot mo obviously. So after knowing the forces acting on the object, you start by drawing a free body diagram. So ganito. So for example here, this particular example, you have three forces acting on a particular object or a particular body. You have F1. Supposedly may vector dapat yan. This should have a vector. F2 and F3. These are forces acting on a certain body. And then after that, what you will do is identify the axis and label all the forces. So after drawing sometimes baliktad. Minsan nauuna yung axis sa free body diagram, sometimes baliktad. Nauuna yung free body diagram sa axis. Kasi minsan, mas madaling i-drawing yung free body diagram pag may coordinate axis ka na. But nonetheless, the point is dapat nauuna yung dalawang yan. So ngayon, ang sinasabi ko last time, dependent yung mga measured mong quantity sa coordinate system. But nonetheless, the magnitude of the forces should still be the same regardless of your coordinate system. Dapat, since magnitude is independent in a sense, you will see that later that the magnitude independent yan kung paano mo kinonstruct yung coordinate system mo. Ang pag-pulling ng coordinate system, nakadepende yan kung sa paano padadaliin yung problem. So kung ano yung pinakamadaling approach dun sa problem, ganun yung gamitin yung coordinate system because the physics will never change. Kahit paano coordinate system yung gagamitin nyo dyan. While the measurements may change, kasi nga, for example, in velocities, for example, di ba, nagbabago yung quantities relative to one another. But sa forces, especially on the magnitude and direction of the forces, of the net force, for example, hindi yan nagbabago. Yung representation lang niya, dun sa coordinate system mo, yung nagbabago. So for example, meron akong object, nakaturo dito yung force. Kahit if I use this coordinate system, nakaturo pa rin dun yung force. If I use, for example, another coordinate system na paganyan, nakaturo pa rin dun yung force. Hindi nagbago yan. Yung physics, hindi nagbago. So pag may tunulak kang cart, regardless kung paano tinignan yung pagtulak ng cart na yun, it will still be the same. Now, so therefore, we have that power to choose the coordinate system that will make our life easier. Yun yung sinasabi nito. You can identify your coordinates axis. The magnitude of the forces and the direction of that force will not change, but the representation may change. Okay? Naintindihan? Naintindihan? Kumbaga nakaturo pa rin dito. Pero ang hindi lang ang nagbabago lang kung anong ibig sabihin ng angle na to. Pwede yung angle na to 'yon, di ba? Yung angle nagbabago, pero yung pagkakaturo niya doon sa directionan hindi. Hindi mo naman inikot 'yan eh. Okay? Questions? May tanong? May tanong?
Yeah.
Okay, thank you for your responses. So in this particular example, it's easier to rule of thumb, madaling mag-decompose ang forces kung yung iba sa kanila, iba sa mga forces ay nakapoint na dun sa axis na kino-consider mo. Usually ganon. Pag mas may rule of thumb na kapag mas maraming forces na naka-act and they're perpendicular to each other, of course, doon mo ilagay yung coordinate axis. Okay? Yan. May ganong rule of thumb. Of course, arbitrary naman yan. Pwede mo nga ilagay dito sa F1 eh. Pero in that case, magde-decompose ka sa F2 tsaka F3. Mas marami kang i-decompose. Unlike in this particular case na yung F2 tsaka F3 mo, naka-point na dun sa axis, hindi mo na kailangan mag-decompose. Isa na lang i-decompose mo, which is F1. Di ba? Speaking of, yun yung susunod na step. You decompose the forces, identify the components based on your coordinate system, and then determine these components. So for example, for F1, you identify the components of F1, so therefore it has X and Y components in this direction, F1X and F1Y. Malinaw ba yon? Malinaw? So it all starts with drawing the proper free body diagram. All starts with drawing the proper free body diagram. Questions? May tanong ba?
Wala.
Wala. Okay. Now, the next one is, again, you set up the equation of motion. Ang tawag sa isa-set up yung equation ay equation of motion. So kapag may tagtanong sa inyo, what is the equation of motion? Yun lang yung net sum of all forces on X and net sum of all forces along Y. Equation of motion. So do not forget that. Ang tawag dyan ay equation of motion. Okay, after setting up the equation of motion, you can solve it algebraically. Systems of equations yan. So ang gagawin mo, for objects at rest, this is 0. For objects in motion, hindi yan 0. For objects that are accelerating, mali pala ako. For objects that are rest or moving with constant velocity, this should vanish by Newton's first law. But for objects that are accelerating, this should be equal to ma. Okay, pero ngayon kasi since statics pa lang naman tayo, 0 lang yan. And then, for the FBD shown like this one, ang mangyayari, you, assuming that positive x ang to the right, positive y ang to the upward, we get these two equations here. Summation of forces acting on x equals 0, giving us f1x minus f2 is equal to 0. Summation of forces acting on y equals 0, we get f1y minus f3 is also equal to 0. Okay, so we have two equations here. Okay, depende dun sa tinatanong, halimbawa dalawa pala yung tinatanong, ilan yung kailangan mong equations. Okay, so if you have equations, obviously you will have equations, you need to solve what's being asked. So ganito, ilan equations ang kailangan mo if you have 3 unknowns? Ilang equations ang kailangan mo if you have 3 unknowns? Obviously, dapat 3 din. If you have n unknowns, you need n equations. Huwag kakalimutan yon. And then you need to solve them simultaneously. So, naalala nyo ng diagnostic exam, doon sa mga students ko, nag-diagnostic exam tayo, di ba? One of the problems is to how to solve a system of equations in 2D. Babalikan natin yun. Okay, this will be important in this topic and then the next 2 topics. Kasi this topic is basically solving systems of equations. Okay? Clear ba tayo doon? Clear ba tayo doon? Malinaw ba to?
Yes, sir.
Okay.
Yes, sir.
So another problem solving tip here for problems with inclined plane. Usually, this is only true. Itong tip na to, this is only true if the plane is only a plane and not rotating. We will see kapag dun sa dynamics of circular motion that this is not always true. Pero for the meantime, kung may plane ka sa incline, may object ka sa inclined plane, mas madaling i-decompose yan into one that's parallel to the incline, that will be your x, and one that is perpendicular to the incline, that will be your y. And the decomposition of weight, huwag kakalimutan to, baliktad. Yung y component ang cosine, yung x component ang sine, where the angle here is the angle of the plane relative to the ground. The angle of the inclined plane relative to the ground. Okay? Baliktad. Cosine ang y, sine ang x. So, paano nakuha yan? Use your trigonometry to get it. You can derive it. Okay, but for the meantime, since I have no time to derive this equation, W cosine theta itong y component, W sine theta yung x component. Okay, clear? Again, it's easier for inclined planes for you to decompose it one parallel to the incline, one perpendicular to the incline. Because you will see na yung, for example, the tension and the normal forces there, they will automatically be pointing at the axis. Hindi mo na kailangang i-decompose. Unlike, for example, if we use, let's say, x and y here, ang dami mong i-decompose sa forces dyan. Okay? It's easier to decompose the weight. Clear ba tayo doon? Clear ba? May questions?
Yes, sir.
Okay. So, there's also, I've added some ideas here. Problem solving guide, make a rough sketch of the system, set up the coordinate system, draw the free body diagram. Ayun, sa akin, usually baliktad. Nagsiset up muna ako ng coordinate system bago mag-draw ng free body diagram. But also, it's also possible na mag-set up muna ng FBD bago ka mag-set up ng coordinate system. Either way, dapat mauna yung dalawang yan. And then, decompose the forces using the coordinate system. And for bodies in equilibrium, do not forget that these all vanish. These all vanish. Okay? Summation of forces equals 0 in x, y, and z. And after that, solve for the quantities. This is basically your systems of equations. Clear ba tayo dito? Clear ba tayo dito? Questions?